Section 14 is the vocabulary of functions. In the warm-up, we're asked to review a little bit about what we already know about equations. So the first question on number 1 and number 2, they're both graph representations of a function. We're asked to find the slope. So the slope for a linear function, we're going to look at how much the vertical coordinate changes compared to the horizontal coordinate. So if I start at a point here, a known point, 0, -2, that's a pretty easy one to pick out. I can go up 1, 2, 3, 4 until I get to the next point over here, and then I have to move over 1 in the positive direction. So I have a vertical change of 4 and a horizontal change of positive 1. So that will reduce down to 4. The y-intercept is the value where the line will cross the y-axis. Again, this is the y-axis, and right there we have our point at -2. So that is our y-intercept. Number 2, similar type of situation, but now we have a graph that's going in a different direction. So here I picked out the points 0, 3, and the point -3, 5 is my known points. I could have picked others, but those seem to be the easiest ones to pick. So to go from the point at -3, 5 to the point at 0, 3, I had to move down 2, and I had to move to the right 3. So a vertical change of -2 and a horizontal change of +3. So my slope would be -2/3. That does not reduce. And the y-intercept, again, is the value where it crosses the y-axis, so that's right there at the point 0, 3. The value is 3. Now a table is a little bit different, because a table we don't have that visual representation of the function. We got to actually look a little bit more at the data itself. These values right here, the ones on the left-hand side are inputs of the function, and the ones over here are the outputs of the function. We can start to think of these as ordered pairs. So -3 of an input, 7 output, is really an ordered pair of -3, 7. The same thing here, 0, 1, and 2, -3. Because it's a linear function, we know that any 2 points that we pick, we can find the slope between those, and it should be the same. So I can find the slope, and I chose here to find the slope between positive 1 on the output down to -3. So right there, that's a vertical change of -4. And then here I have a change of +2 in the horizontal. So slope is going to be the change in the output or the vertical coordinate over the change in the input or the horizontal coordinate. -4 divided by 2 becomes -2. I can also choose the points here, -6 for the pattern and +3, and I end up getting the same thing for the slope. So I verify that it does actually work. Now the y-intercept is when the x-coordinate or the input equals 0, the value of y at that particular time. So if I'm looking at the inputs, there we go, we have a 0, the output is 1. So that is my y-intercept. For questions 4 and 5, these two functions are written in the form f of x equals mx plus b. And this guy right here is our slope, and the b value is our y-intercept. So the slope in this case is the number in front of x, it's 4. There it is. And our y-intercept is the other number that's not attached with the x, at -3. On number 5, we do the same thing. The number in front of x, that is our slope, -3/7. And the other number is +1. And there we go. In activity 1 on section 14, we're asked to find 3 different things. We're asked to find the zeros of a function. We're asked to find whether a function is increasing or decreasing, and to say where that is. And then we're asked to find out which ones are constant functions. So the zeros of the function, that's really another way for us to ask about the x-intercept. It's where the graph is going to cross the x-axis. Increasing and decreasing is just another way for us to ask about the slope of a function. So we'll take a look at all the graphs and try and figure out their slopes and where the zeros are. And we'll also talk about the constant functions. So looking at our graphs here, we're going to start with A, B, C, and D. So graph A, I'm going to first look at the intercept, so the x-intercept, in this case the 0. And I have a positive value right there. So my x-intercept will be a positive number, and that's what we also call the 0. It's called a positive 0, which sounds really strange to think about, a positive 0, but it's the same thing as an x-intercept. And the function is increasing because the slope is positive. So slope positive gives me an increase. It moves up from left to right. In graph B, we have a negative value for R0. And as we move left to right, the function is falling. So that's a slope of a negative number, which gives us a decreasing function. Graph 3 is not going to cross the x-axis at all. There is no 0. And more importantly here, the slope is the same throughout. And it's 0. It's not changing at all, and it's just going to be 0. We're not moving up, we're moving over, but we're not moving up at all. So in this case, this is what's called a constant function. And we have to be a little bit more specific. A function of what? Well, if we move left to right, if I start plugging in x values, so -5, -3, and so on, I know exactly what my output is going to be. So this is a function of your input, which is x. Yes, the equation is y = 2, but it's not a function of y, because if y is the input, we have to know what the output's going to be. And here we do. So, and again, no zeros. Graph D, we have a positive x-intercept, so a positive 0. And the slope is going to be negative, which indicates a decreasing function. And graph E, we have a positive x-intercept, a positive 0 right here at 2. And the graph is falling as we move left to right. We've got a negative slope, which means it's decreasing. And F, positive x-intercept, or positive 0. Our slope is positive as well, which indicates increasing. For graph G, we've got a positive x-intercept right there, so positive 0. And the graph is rising as we go left to right, so it has a slope that is positive, and it's also increasing. For graph H, we have a negative value here, so negative 0. And the graph is falling from left to right, so that's a slope of a negative value, decreasing. And graph I, this is kind of an interesting one here. There is an x-intercept, so we know that for sure. So x-intercept is at 2. So we've got a negative value here. Here's the cool part about this function, and we're going to be careful about that word function. It does go vertical. Now, it is a function, but it's not a function of x, because if I plug in -2 as my input, I could get 1, 2, 3, 4, 5, a lot of different things for the output. That's not predictable at all. The input of -2 returns multiple outputs. However, if I said my input was y and I started at 2, I know what x has to be. It has to be -2. If I start at 4, I know that x has to be -2. Yeah, it's the same output, but that's okay. It's predictable. We have an input that has a known output. So this is a constant function. Of y. Yes, the equation is x equals -2. However, it's a function of y. On to graph J. J, we have a -0, and we have a decreasing function because we have a negative slope. So slope is negative, which means it's decreasing. And we've got 2 more here. On K, we actually have a 0 right there at 0. So we have one of those that the 0 is equal to 0 of the function. Is that x equals 0. And we can tell from the graph's moving up as we move from left to right. It's rising, so we have a positive slope, which indicates increasing. And then the last one here, we have the same 0, so x equals 0, and then the graph is decreasing as we move left to right. So we're going to say that that's a negative slope. Oops, wrong color. There we go. Slope. Oh, did it again. I'm sorry. There we go. Slope is negative, which means the function is decreasing. Main idea from this part of the activity is that the 0 is the same thing as the x-intercept. A positive slope means the function increases, and a negative slope means the function decreases.